Hey everybody, I know you've been waiting for this video. This is lesson 5-7. This is the very last section of this chapter. And these notes are on inequalities in two triangles. So let me explain something to you so that you understand that we're not learning a different concept. We're learning a different application of the same concept. In other words, we've talked about in previous lessons that the biggest side is across from the biggest angle. That's when we're in one triangle. And we talked about the biggest angle being across from the biggest side. And again, that was inside of one triangle. That's why it's called the triangle inequality rules. All right, this is inequality in two triangles. Okay, so that means you're comparing two different triangles. Now, the key to this is we're not just comparing the two different triangles, but what do you notice about the two triangles? And hopefully you've been reading this while I've been talking, and you should be able to tell me that this is a rule that involves only if two of the sides are congruent. Okay, so it's a comparison of which side? Correct. Hopefully you chose that it's a comparison of the side that doesn't have the congruency marks. Right. So in other words, we're comparing this angle here and the side across from it, and this angle here and the side across from it. Excuse me. So the concept still stays the same. The bigger angle is across from the bigger side. The difference is these two triangles have two sides that are congruent. That's why we can do this comparison. It's called the hinge theorem. Okay? The hinge theorem, like the hinge on a door. Notice, your door and the door jamb always are going to be the same. So let's pretend this was the door jamb. That means this would be the door that closes. And as you open it up, the longer the distance is between the open door and the corner that you closed it against, the bigger this angle is. All right? So if I told you that this side was 4 and this side was 10, you could tell me which angle is bigger. Now you can only do that if the two sides are congruent. If these congruency marks aren't here, or there's not equal measurements here, this rule doesn't work. It only works if the two sides are congruent. Then the side across from the angle is going to be as big or in proportion to the side across from this angle. So here we are, we have two sides that are congruent of two different triangles, which means which one of these is bigger? 10. So which one of these angles is bigger? M. Correct. The bigger angle is across from the bigger side. Okay, but two of the sides must be congruent. Smaller angles across from the smaller side. Well, let's say we goof this up. Let's say I put this as 4x minus 2. And this is still 10. Well, now I've changed the look of the problem. The concept's still the same. Okay? If I tell you that ln is bigger than AC, that means AC is smaller than 10 or less than 10. So we're not dealing with equal to's because these are called inequalities. Inequalities are less than, greater than, less than or equal to, greater than or equal to. In this case, we're just dealing with less than or greater than. So being that I told you the angle was smaller or this angle was bigger, this side would be smaller or this side would be bigger. Okay, however you want to look at it. And I write out my inequality. Does my math work change? No, I still do the same math. So that tells me I'm going to add 2, and I'm left with 4x is less than 12. I divide by 4, And I'm left with x is less than 3. And this would be my answer for x. If they asked me for this answer, what could this side be? Hopefully you know I'd have to pick a number that's what? Correct, smaller than 3, but what has it got to be bigger than? Hopefully you know it's got to be bigger than 0, right? It can't be 0 because that would make this a -2, and we can't have negative distances. So you have to know common sense wise, all of these answers are got to be positive, and they have to be bigger than 0, which means they're positive. So if I wanted to, I could stick a 1 in there. That'd be 4 minus 2, which is 2. Okay. So you just have to be careful, because on the quiz, a lot of you missed problems, especially that one problem where they say, what is the measure of something? You found x, which was fantastic, but then you didn't plug it back into the problem and solve. All right? So understanding what the hinge formula is, that you could tell me which sides are longer based on which angles are longer, and you could tell me which angles are longer based on which sides are longer. Okay? And they do several different examples of this in the book. One of them is a pair of scissors. Okay? And then they ask you, okay, one of them is a pair of scissors, and you'll see they give you 2 pairs of scissors. They look at it and they go, okay, so which one is open wider? Which one has a longer distance from the end of the sharpened scissors to the end of the sharpened scissors? Now, I'll show you. Scissors look like this, right? And here's one pair of scissors. Okay? And they're talking about this distance. And then here's my other pair of scissors. Okay? And they say the angle measurement of this one is 23 degrees. So inside of here is 23 degrees. And then inside of here is 40 degrees. Which pair of scissors is wider open? Hopefully you know that it would be this pair is wider open. Okay. And that's called the what? Hinge theorem. Okay, so let's look at another example of this. We have to be able to go forwards and backwards if the angles are bigger than the sides, and if the sides are bigger than the angles are bigger. Well, let's look at something a little bit more different. Let's look at a complex picture where things aren't so clear-cut. But the concept remains the same. So here we have a measurement of 15. Here we have a measurement of 10. Here you have a measurement of 60. And here you have a measurement of 5x minus 20. So here we go. This is where we kind of start pulling everything together. And I'm going to tell you that the congruency marks were here and here. Now the hinge rule only works if we have 2 sides that are congruent. And then the angle in between those 2 sides is used to compare to the sides. Well, I see one pair of congruency marks. Can anybody tell me where the other pair go? And I'm hoping you say you still must be able to see reflexive sides. So now I have 2 triangles that have 2 sides that are congruent. So that means the angles across from them should work in unison. In other words, which of the 2 sides is bigger? That means across from those sides, which angle is bigger? Okay, so 15 is bigger than 10, which means 60 has to be bigger than 5x minus 20. So to write that out, I'd have 5x minus 20 is less than 60. And then I can do my math. Add 20, 5x is less than 80. Divide by 5, x is less than 16. So that means I can use any number for x other than 16 or anything correct higher. All right, so knowing it forwards, knowing it backwards. That's called the hinge theorem. It's when we use the same concept, bigger sides are across from bigger angles. The idea is we have two different triangles to pick from. And we still have to notice reflexive sides and reflexive angles. You're still going to have to know where those are at. All right? And that is 5-7 in a nutshell. It's not really long because the concept's not difficult. It is all based on the same concepts we've learned, except we're now comparing two different triangles, and we have to make sure two of the sides are equal to each other. And notice, the angle we're comparing must be between the two sides. And that's the idea. Like the hinge of a door. Imagine A closing. Okay? Imagine L closing. That's what we're dealing with. All right. Work well.